Hi again. Well, last time I left you on kind of a cliffhanger because we calculated a confidence interval and we did capture our true mean. And I hope you caught my error on the last one. I wrote proportion. I'm more used to doing proportions than mean, so I'm going to work on that. We did capture the true mean of 4.51 million, and I fixed it in the question up here as well. So yours should be correct. So we did capture the true mean that time, but I also mentioned we won't always capture it. So how often would we expect to capture the true mean? Or if I just said parameter, that would be more general, right? Okay, so let's go to the next page and the meaning of confidence level, okay? So I want to remind you of a couple things. Remember, the parameter is fixed, but unknown. We don't know it. That's why we're doing statistics in the first place. And by comparison, the point estimate, that's our statistic, is known, but it varies, okay? And that varies from sample to sample with just regular sample to sample variation. So this varies sample to sample. Okay, so instead of using something like probability, we use the word confidence to convey that the uncertainty is in the confidence interval, not in the population parameter. Okay, so the interval is what's moving around. Okay, so the interval varies from sample to sample, not the parameter. If we said something like there's a 95% chance that the true parameter will be in the interval, that sounds like the parameter's moving around and the interval is fixed. But that's not what's really happening. The parameter is what it is. We just don't know what it is usually. And the interval is varying. Okay, so let me show you that. Let's go back to our simulation. And let me show you that. Okay, I had to make sure I cleared out my stuff. I don't want any spoilers. Okay, so here we had our one sample, and this might actually be a different sample, but than what we had before, because I screwed up and I had to redo this video a couple times. Kept saying proportion instead of mean. So we had our sample here. We have a sample here. It's actually 5.973 million, so it's a little higher than what we got. But I'm going to go over to confidence intervals on the right-hand side. There's a tab up at the top. And this shows you, I really love this view because here it shows us, this is one sample of 5.973 million. And then here's the interval. So this is minus the 2 standard errors and plus the 2 standard errors. Standard error is the same, right? Now, we wouldn't normally do this, but just because we can with simulation, I'm going to do another one, okay? And you'll see if we take another random sample, again, of 50 baseball players, we get a different sample mean. And then we calculate the interval. This one also captures, and it's green. They show up green when they capture the true proportion. And this line, I should mention this line, vertical line down the middle, and there's a mu at the bottom, that is the true proportion. So that is fixed, okay? It is what it is. Okay, just do a few more. Okay, here I got a red one, and you can see it does not cross the line. So this just was a little too high. It oversampled the higher paid baseball players and undersampled the lower ones. But that can happen in a simple random sample, right? So we missed that one. So let's keep going. Most of them are capturing the true proportion, though. See if we can get another one that misses. Okay, so now I'm up to 20, just going one at a time. And we have one that misses. Okay, think about what percentage that is. But I want to get up to 100, because then we don't have to convert. I'm going to go by 10. So I'm going to click on the Generate 10 Samples. Oh, I guess it has the coverage percentage right here, so I should have looked at what that was. Okay, so now I'm up to 50 and 2 have missed, so that's 96% coverage. In other words, 96% have captured the true mean. Okay, I'm going to keep going. 70, 80, 90, 100. Okay, wow. So still only 2. See how this, I really love how this shows the sample to sample variation in a different way. And then you can see it on the dot plot here as well. That's the other way we looked at it, but I really like how this shows it also. Okay, so this time we got 98% coverage. And what 95% confidence means is we expect to capture the true mean or the population parameter around 95% of the time. But again, there's variation in everything, so the actual percentage will vary. Okay, so let's try another 100. If you reset your plot, click on Reset Plot there. And then you can go by ones again if you want, or you can just click Generate 100 Samples. Okay, so this time we got exactly 95%. 5 are missing, 5 are not capturing the true mean, and they're all on the high side, which is interesting, but you know, just random, just due to chance. You can see some samples get very close where the sample mean is really close to the population mean, right in the middle there. And those are also the ones that are right in the middle of our dot plot on the left here. Okay, so let me do another one. Reset plot, generate 100. Okay, this time 94%. So this time actually 6 missed, so a few more than 5. But it's still pretty close to 5. And some of them don't miss by much, right? It's very close, so it's just right below or right above. Reset plot, another 100, another 94. So a couple of these were, this one, bottom one was way off. Reset plot, another 100. So now I got 96%. So if I did a bunch of these, it should average around 95%, right, in the long run. I'll do a few more. I can't stop. It's so much fun. There's 3 that missed that time. Exactly 5 that time. 6 missed that time. I've got 94% coverage. Okay, one more. I promise I'll stop. Okay, 98%. So only 2 missed there. So we never know whether we have a green one or a red one, right? In real life, we do our best job at sampling to take a random sample, a representative sample, and then we have a certain, let's say we have 95% confidence that we've captured the true proportion, true mean, true parameter, whether it's a mean or a proportion. Okay, so let's go back to the notes and summarize this. Okay, so we generated our 100 confidence intervals to understand the meaning of this is mostly the confidence level, but it does kind of show you shows you a lot of things. Okay, so here I put these 2 graphs on the notes for you. The graph on the left has one confidence interval, and this is our the one we originally did in our sample. And at the bottom we've got mu. I'm just gonna need to raise it up more. At the bottom of the graph we've got mu, which is the solid line. So I'm gonna actually just draw it in pink just to remind you, especially if you're looking at your notes later on, that solid line going down the middle, that is the true mean, true population mean, or I could say parameter to be more general. Okay, and then in this particular simulation that I did on the right, you can see it says 97% coverage at the top. So there were 3 that missed. So I'm just going to highlight those so you can see that later on. So that one missed to the right. There's another one that missed to the right, and it looks like there's one that just barely missed to the left. I think it's down at the about 2/3 of the way down. Okay, so those missed. So I'm just going to put a note, missed the true mean. And we had 3 out of 100 that time that missed the true mean. So then just to summarize, I'm going to say we expect to capture the true mean 95 times out of 100. And then I'll say on average, right? Because this varies. Okay, it varies just like everything with randomness. Okay, and then I've got a few notes down here just to summarize. If we were to take random samples over and over again with the same sample size, remember this was n equals 50 the whole time, each time we would get a different sample statistic, or also called point estimate. In this case, that was x bar, because we were doing means. And then we get a different confidence interval each time, right? Different confidence interval. And that's, we're using the plus or minus 2 standard errors for that. Then about 95% of these confidence intervals would capture the true mean, and about 5% would miss the true mean. Okay, great. Well, I'll see you in the next video.